Episode 12. Ancient Light. Could life be billions of years old? Hook. Visualization. Curiosity. Hook. Imagine a civilization that has been evolving for not millions but billions of years. A civilization that was already ancient when the dinosaurs walked the earth. A civilization that has had time to solve every problem we face: disease, energy, gravity, perhaps even death. What would such a civilization look like? What would it be capable of? And would we even recognize it as a civilization at all? These are not idle questions. They are among the most important in all of science, and the answers, if we ever find them, will tell us something profound about the ultimate destiny of intelligence in the universe. The universe is 13.8 billion years old. Earth is 5 billion years old. Life on Earth has existed for about 4 billion years. Intelligent, technological life, humans, has existed for perhaps 300,000 years and has been capable of space travel for less than a century. We are extraordinarily young. We are, in cosmic terms, newborns. And yet we have already developed the ability to split the atom, sequence the genome, and send spacecraft beyond the solar system. The pace of our development has been breathtaking. Now imagine that pace sustained, or accelerated, for 1 billion years. But the universe has been making planets for most of its history. Some of the stars in our galaxy are 10 or 12 billion years old, more than twice the age of our Sun. If those stars have rocky planets in their habitable zones, and some of them do, then life on those planets has had an enormous head start on us. If life got started on such a world as quickly as it did on Earth, it could have been evolving for 8 or 9 billion years. And if intelligence evolved on such a world, that civilization could be billions of years more advanced than we are. Billions. Not thousands, not millions of billions. What does 1 billion years of technological development look like? We have no idea. We can barely imagine 1,000 years of development. 1 million years is beyond our intuition. 1 billion years is simply incomprehensible. But we can try to reason about it by extrapolating from our own trajectory. In the last 200 years, we have gone from horse-drawn carriages to spacecraft that have left the solar system. We have gone from candlelight to nuclear power. We have gone from sending letters by hand to instantaneous global communication. The pace of technological change is accelerating. If that acceleration continues, and there is no obvious reason why it must stop, then a civilization 1 million years ahead of us would be as far beyond us as we are beyond the bacteria that first appeared on Earth. And a civilization 1 billion years ahead of us would be so far beyond that comparison that we may not even have the conceptual vocabulary to describe it. The physicist Michio Kaku has proposed a classification system for civilizations based on their energy use called the Kardashev scale. A Type 1 civilization uses all the energy available on its home planet. A Type 2 civilization uses all the energy of its star. A Type 3 civilization uses all the energy of its galaxy. We are currently somewhere around Type 0. 7. We haven't even reached Type 1 yet. A civilization that has been developing for billions of years might be a Type 3 civilization, harnessing the energy of hundreds of billions of stars. What would such a civilization look like from the outside? It might look like nothing we would recognize as technology. It might have restructured its galaxy in ways that we would interpret as natural phenomena. It might communicate in ways that are invisible to our instruments. It might exist in forms, digital, distributed, post-biological, that we don't have categories for. This is the idea behind the search for Dyson spheres, hypothetical megastructures built by advanced civilizations to capture all the energy of their star. A star surrounded by a Dyson sphere would appear dim in visible light, but bright in infrared, as the structure radiates waste heat. Astronomers have searched for such signatures in astronomical data, And while no confirmed Dyson sphere has been found, the search continues. The discovery of Tabby's star, with its bizarre, irregular dimming patterns, briefly raised the possibility of a partial Dyson sphere before more mundane explanations were found. But the search for technosignatures of this kind is now a legitimate and growing field of astronomy. Researchers are systematically scanning catalogues of stars for anomalous infrared signatures, unusual dimming patterns, and other signs of large-scale engineering. There is another possibility that is even more mind-bending. Some physicists have speculated that a sufficiently advanced civilization might not just use the energy of its star or galaxy, it might manipulate the fundamental structure of space-time. It might create wormholes, or engineer new universes, or find ways to survive the eventual heat death of the cosmos. These ideas are speculative in the extreme, but they are not forbidden by the known laws of physics. And if a civilization has had billions of years to work on the problem, who knows what it might have achieved? The history of science is full of examples of things that seemed impossible until they weren't. Heavier than air flight, nuclear energy, quantum computing. Each generation draws the line of impossibility in a different place. There is no reason to assume our generation has drawn it correctly either. The existence of ancient advanced civilizations, if they exist, raises a profound question about the Fermi paradox. If such civilizations are out there, why haven't they made themselves known to us? One possibility is that they have and we haven't recognized it. Another is that they are aware of us but have chosen not to interfere, a kind of cosmic prime directive. Another is that they have transcended the physical universe in some way and are no longer detectable by our instruments. Or perhaps they are simply too far away, and the signals they send take so long to reach us that we haven't received them yet. Or perhaps the universe is so vast that even a Type 3 civilization, spreading at a fraction of the speed of light, has not yet reached our corner of the galaxy. If you're enjoying this journey through the cosmos, subscribe and stay with the series. We're in the final stretch, and the last 2 episodes are going to bring everything together in a way that I think you'll find genuinely moving. The possibility of ancient life, of civilizations that have been evolving for billions of years, is one of the most humbling ideas in all of science. It puts our own brief existence in perspective. We are not the end of the story. We may not even be the beginning. We may be a single note in a symphony that has been playing for longer than we can imagine. And that thought, rather than diminishing us, should fill us with wonder and with the determination to keep searching. We're almost at the end of the series, and the next episode asks what all of this means for us right now. Subscribe and keep watching. Don't stop here.